Okay, let's have a talk here about horizontal asymptotes for rational functions. And as you can see, I have 4 rational functions here, and we're going to look at each of them and investigate the horizontal asymptotes. Now, before we begin, let's quickly talk about what a horizontal asymptote actually is. Unlike a vertical asymptote, horizontal asymptotes are not related to domain problems. So if you think of a vertical asymptote, they're associated with where the denominator of the function works out to 0, specifically what happens as the x value gets closer to the value that makes the denominator work out to 0. So vertical asymptotes are related to domain issues, to division by 0. Horizontal asymptotes, on the other hand, are not related to domain problems. They are related to end behavior. Horizontal asymptotes are really just a number that the graph gets closer and closer and closer to after a while, either on the left side or the right side of the graph. So they're related to end behavior. They don't have anything to do with domain issues. So how do we find them? Well, let's take a look at the idea behind horizontal asymptotes by starting with a really simple function here. We have y equals 2 over x plus 5. Now the question is, what is the horizontal asymptote, if any, for this function? And the way to figure it out is, for now, just to think about what happens as x gets really, really big. And we'll start by thinking about what happens as x gets really, really big on the positive side of the graph, so approaching infinity. What happens is does this start to approach some number? Well, just imagine x getting huge, okay? What would happen to the value of this whole function when x gets really big? Well, as x gets really big in the positive direction, the denominator here is going to become really, really big. The numerator is not changing at all, though. It's just 2. So what happens as you start doing 2 divided by a number that's getting really, 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 really big? Well, the bigger that x gets, the closer to 0 this result is going to get, because you're dividing by a really, really big number. So after a while, and it won't take too long, but after a while, as x gets bigger, this graph is going to get really, really close to 0 because the denominator is getting huge. And that's going to make it look like it has a horizontal asymptote at 0. Now that'll also happen if x gets really, really big on the other side, the left side of the graph. If you imagine x approaching negative infinity, so really big negative numbers, the bottom here would become a really, really big negative number. So when you do 2 divided by that really big negative number, you're still going to get a number that's close to 0. The further you go to the left of your graph, right, the more negative x becomes. The result of this whole function here is going to get closer to 0. It'll just be negative instead of positive. So we can say that this graph here, this function, has a horizontal asymptote of y equals 0. And we always write y equals because we're talking about the equation of a horizontal line. And all we're really saying here is that as x gets big, either positive direction or negative direction, this function starts to look more and more like the number 0. So the graph looks like it's approaching the line y equals 0. And that's the big idea. And now you can extend that idea to more complicated looking functions. Okay, so let's take a look at this one here. All you really have to do is use the same type of reasoning we just did for that simpler function. What happens as x gets really, really big? And for simplicity now, let's talk about x getting big in the positive direction. Well, as x gets bigger and bigger and bigger and bigger and bigger, this numerator is going to grow. But it is not going to grow nearly as quickly as the denominator. And why is that? Because the denominator has an x squared. And that makes the denominator become larger much faster than the numerator. So what happens is, as x gets bigger and bigger and bigger and bigger, both the numerator and the denominator are growing, but the denominator is much bigger relative to the numerator. So you have a fraction that's becoming significantly, or I should say relatively, much larger on the bottom. And as we've seen, when the bottom becomes much larger than the top, you start to get results closer and closer to 0, right? The bigger this is compared to this, the closer the result will be to 0. And the same thing will happen here if you approach negative infinity. So getting really big negative numbers for x, you're going to get huge numbers here, they'll be negative. You're going to get huge numbers here, they'll actually be positive because you're squaring. But in the end, the point is, the magnitude of the number on the bottom is going to be significantly larger than that on the top. So you're going to get a result closer to 0. So we could say again that the horizontal, and I'll summarize all this at the end of the video, horizontal asymptote is y equals 0. Okay. Now sometimes we can also think of this a slightly different way. I'll just kind of show you this. We have 3x plus 7 over x squared plus 5x minus 8. You've probably seen end behavior before with polynomial functions. And let's just look at the numerator. As x gets really, really big, this 7 becomes more and more insignificant. So after a while, the numerator just starts to look like whatever the value of 3x is, because 7 is so small compared to the value of 3x once x gets big. The same kind of thing happens in the denominator. Once x gets huge, the 5x and the minus 8 are insignificant compared to x squared, so that it starts to look more and more like whatever the value of x squared is. Now, of course, this is just 3 over x. And when you look at it this way, it's almost like looking at the simple function here. What happens as x gets bigger? Well, that denominator gets really big compared to the numerator, which is just a constant here. So this is going to approach 0 over time, which is why we have that look of the graph, approaching the line y equals 0. Now, we have 2 here with a horizontal asymptote of y equals 0. Is that always going to happen? No. But why did it happen here? Well, for a very simple reason. If we look at our numerator and denominator and compare the degree of those polynomials, we always had a higher degree polynomial in the denominator. Here we have a degree 1 polynomial, where we just have a constant in the top. Here we have a degree 2 polynomial, but just a degree 1 in the top. So is it safe to say that as long as the numerator is lower degree polynomial than the denominator, we're going to have a horizontal asymptote at 0? Absolutely. Same type of reasoning will always occur as long as this is a lower degree than this. What, though, happens if it's a higher degree? So this is a degree 3 over a degree 2. Well, it's kind of the opposite. As x gets bigger and bigger and bigger and bigger, this stuff will kind of become insignificant. But the point is, what will happen is the numerator, because of this x cubed, is going to become relatively way larger than the denominator because it only has x squared. And when you cube something, you get, for big x values, cubing it gives you a significantly larger result than just squaring it. So yeah, over time, whether you're approaching really high positives or really high negatives for x, in terms of just like size and magnitude of the number, you're going to get much larger numbers on the top relative to the bottom. And what does that mean in terms of results? Well, it means it's not going to approach any specific number. It means as x gets bigger and bigger and bigger, you're just going to be getting bigger and bigger and bigger results for this whole function because the top is significantly larger than the bottom. Now, they might be bigger positives, bigger negatives, depends on the signs of the numerator and the denominator. But the point is, if the numerator has a higher degree polynomial than the denominator, you're not going to approach any number, which means you have no horizontal asymptote. Okay, and will that always be true? If you have a higher degree in the numerator than the denominator, there's no horizontal asymptote? And the answer is yes. And again, I'll summarize this at the end of the video. Let's look at one more example here. What if the degree of the numerator and the denominator is the same as it is here? Okay. Well, we actually can use kind of the same type of reasoning. Let's imagine what happens as x gets really, really big. Well, as x gets really, really big, then we'll think about positives for now. You could also do this with negatives. Same idea applies. But really big positives, well, after a while, the 5x and the minus 2 will pale in comparison to the size of 6x squared. It'll just look so much bigger, 6x squared, that it'll make the other two terms look insignificant. So we could say that this approaches 6x squared. And what about the denominator? Well, after a while, once x gets huge, this and this won't even really matter. I mean, they'll still have an impact on the result, but insignificant. So it's going to approach 6x squared over 2x squared is what this graph is going to start to eventually look like as x gets, really, really big. But wait a minute, 6x squared over 2x squared, those x squareds just divide out, and that leaves you with 6 over 2, which is just 3. So what does that mean? Does that mean that this graph eventually starts to look like 3? And the answer is yes, it does. And that is your horizontal asymptote. For this reasoning, after a while, once x gets really big, positive or negative, this graph just starts to look like whatever this number divided by this number is, because the x squared is divided out. And we could say horizontal asymptote is y equals 3. And we always write y equals for a horizontal asymptote. And that'll always happen when you have the same degree polynomial in the numerator and in the denominator. All you have to do is divide those leading coefficients to get your horizontal asymptote. So here is a summary for you that that you can write down. Oh, sorry, that's a little tough to read there, isn't it? Let me just move that maybe to a new page for it. Just give me one sec here. There you go. Okay. If you have a lower degree on top, a higher degree on the bottom, you're going to have a horizontal asymptote of y equals 0. If you have the higher degree on top, you're not going to have a horizontal asymptote. And if you have the same degree in the numerator and the denominator, you can find the horizontal asymptote by dividing the leading coefficients. And that is it. So there you go. I hope that helps.